Hey there! If you're a student looking to totally conquer your CS 118 Foundation lecture on C programming, you are in exactly the right place. I'll be your guide through this explainer today, and we're going to take what might seem like super abstract, intimidating syntax and turn it into practical, easy-to-grasp building blocks. Whether you're completely new to coding or just need to solidify your foundation before an exam, we've got you covered. So let's just dive right into it.
All right, here's our roadmap for this explainer. We'll be hitting 1. History and compilation stages, 2. Anatomy of C programs, 3. Variables and data types, 4. Input, output, and formatting, 5. Operators and precedents, and finally, 6. Tasks and exam recap.
Okay, let's kick things off with Section 1, History and Compilation Stages. It is actually wild how fast this language evolved. Before 1970, we had a language called BCPL, which was mainly used for writing operating systems and compilers. Then, in 1970, Ken Thompson streamlined it into a language simply called B for the early Unix system. Just 2 years after that, in 1972, Dennis Ritchie over at Bell Labs evolved B into what we now know as C. The crucial takeaway here is why C stuck around to become a global professional standard. Basically, it perfectly balances high-level, human-readable instructions with low-level hardware control. The result? Incredibly efficient programs that can run on practically any computer architecture out there.
So, you've written some code. What actually happens next? When you type your instructions into a text editor, you're creating what's called a source file. But here's the catch. Your computer's CPU doesn't speak C. It only understands raw machine code. So that source file has to go on a journey, a compilation process to become an executable file that your computer can actually run. Let's break down exactly how those processing stages work.
There are 3 distinct stages you really need to internalize here. Step 1 is preprocessing. A preprocessor modifies your source code right in your computer's RAM before anything else happens. It basically skips over your human-readable comments and handles special directives. Step 2 is the actual compilation. This is where the compiler translates that preprocessed code into object code, meaning machine instructions. It also aggressively checks for syntax errors. If it finds even a single typo in your syntax, the whole process stops right there. Step 3 is linking. The linker takes your object code, combines it with pre-written system libraries, and spits out that final executable file onto your disk.
Moving right along to Section 2, Anatomy of C Programs.
Let's pop the hood and dissect a real C snippet to see the exact structure required to make a program function. Right at the top, we have our header comments, which just describe what the program actually does. Next is our preprocessor directive. Hashtag includes standard input-output.h. Remember step 1 of the compilation process we just talked about? This line tells the preprocessor to go fetch the standard input-output library, which gives us access to things like printing to the screen. Below that, we have void main void. Every single C program on Earth must have a main function. It's the starting line. It's exactly where program execution begins. And that word void, that just means the function isn't returning any data back to the operating system when it finishes.
Distilling all of that down, here are the absolute strict syntax rules your instructor emphasized. Comments have to use the /, star, and */ format. Preprocessor directives always start with a hashtag in column 1. You absolutely must have a main function, and the actual meat, the body of that function, is enclosed entirely in curly braces. And finally, perhaps the absolute biggest trap for beginners, every single statement in C ends with a semicolon. Think of it literally like a period at the end of a sentence in English. Oh, and keep in mind that getch function you'll often see placed at the very end of your code. It's just a handy little built-in tool that holds your output screen open until you press a key on your keyboard.
Next up, Section 3, Variables and Data Types.
All right, so our structural skeleton is built, but how do we actually hold information? We store data in specific memory locations, and we give those locations names so we can find them later. We've got 2 main categories here. Constants are specific, rock-solid values that never change after they are initially set. For example, pi is always going to be 3.14159. Variables, on the other hand, hold values that can change while the program is running. You might start a program with a shoe cost variable holding $56, and then later in the code update it to a sale price of $35.
You can't just name these variables whatever you want, though.
There are strict naming rules, and mastering these early is crucial because they are such easy points to lose on a lab assignment. Keep your names short but descriptive. You absolutely cannot use spaces. The name must start with a letter. Stay away from dashes or mathematical symbols because the compiler will just get confused and think you're trying to do math. And remember, C is completely case-sensitive. The compiler does not mess around here, and uppercase C is fundamentally different from a lowercase c. It will happily fail your entire build if you capitalize a variable name on line 12, but then write it in lowercase on line 15.
Computers are incredibly fast, but honestly, they aren't smart enough to just guess what kind of data you're trying to store. You have to explicitly tell them using data types. We have numeric data, which splits up into integers, meaning whole numbers, like positive 3,580 or negative 46, and real numbers, which handle things with decimal points. Then we have character data, which can be a single letter like A, or a string of characters grouped together, like the city name Arcata. And lastly, logical data, which is just a simple, straightforward true or false.
Let's jump to Section 4, Input, Output, and Formatting.
So remember that stadio.h library we included at the very beginning? This is where it shines. We use its formatting tools to actually communicate with the person using our software. Printf is used to push text out to the screen, and scanf is used to pull keyboard input in from the user. But these functions need to know exactly what kind of data they are handling. That's where format specifiers come in. We use %d for integers, %f for floats or real numbers, and %c for characters. We also get escape sequences like /n to force the text to a new line or /t to insert a tab. Now, your instructor heavily emphasized a massive warning here. When you are writing these statements, make absolutely sure the order of your format specifiers perfectly matches the sequence of your variable data types. If they get out of sync, your program is going to print total garbage.
I really want to echo a pro tip directly from your instructor regarding the scanf function. It says, the ampersand is confusing in the beginning. For now, just remember to include it with the variable name in the scanf statement. The ampersand symbol basically points the computer to the exact physical memory location to store the user's input. My advice, don't overthink the deep memory management mechanics right now. Just train your muscle memory to never, ever forget typing that ampersand inside your scanf commands.
Section 5 is all about action, operators, and precedence.
So we have our data loaded into variables. How do we manipulate it? C relies on very rigid algebraic rules of operator precedence. The computer will ruthlessly follow this exact order of operations, no exceptions. Parentheses are always evaluated first, starting from the innermost nested pair and working outward. Next in line comes multiplication, division, and modulus, and those are evaluated reading from left to right. Finally, addition and subtraction are evaluated last, again from left to right. If you need addition to happen before a multiplication, you absolutely must use parentheses to force the computer's hand.
Beyond just basic math, C gives you a really slick operator toolkit to save time. We have shorthand arithmetic assignment operators. For instance, plus equals means take the variable, add a number to it, and instantly store the new total back in that same variable. We have increment and decrement operators, like plus plus, to quickly just add one to a counter. And here is a critical difference you have to burn into your brain. Look at the equality operators. A single equal sign assigns a value to a variable, but a double equal sign actually checks if two things are mathematically equal. Do not mix those up. It is one of the most classic ways to break a perfectly good C program. And rounding it out, we of course have standard relational operators, like greater than and less than.
And finally, Section 6, Tasks and Exam Recap.
Let's bring all of these concepts together and see how they solve your assigned lecture tasks. Take task number 3. You're asked to print specific ASCII art shapes using asterisks. This is basically a direct test of your formatting skills. You'll need to creatively use the printf function along with that new line escape sequence /n to structure these stars line by line on your output screen. It sounds basic, but honestly, it perfectly locks in your understanding of the essential output commands and statement structures we just covered. To recap everything, mastering the C foundation really comes down to 3 things. Remembering your structural syntax, like always using semicolons and curly braces, keeping your variable data types perfectly aligned with your format specifiers, and strictly respecting that order of operations. And I want to leave you with a provocative thought directly from your second assignment task. You need to read a circle's radius from a user and print out its area. Think about it. How are you going to combine your scanf function to grab the variable, apply the right math operators using your constant for pi, and then output the whole thing seamlessly using the %f format specifier? I challenge you right now while it's fresh to open up your text editor and apply the syntax, the precedence rules, and the studio.h functions we just went over. You've totally got this. Thanks for hanging out with me for this explainer, and happy coding!